Hello, everybody, and thank you for joining our webinar today on CNC simulation with collision avoidance. My name is Ben Weber, Sales Manager at ModuleWorks, and co-presenting with me today is Mark Foti, our Product Manager for CNC simulation. Before I get started with the agenda, I would like to make one important point. Due to the high number of attendees today, we can't take any questions during the webinar itself. So if you do have any questions, please take a note of these and feel free to email me or Mark after the webinar. You will find our email addresses on the right-hand side. So please do take a note of these and feel free to contact us. If you do already have contact with ModuleWorks, then of course, feel free to contact your account manager or the product manager responsible for you. So to tell you a bit about the purpose of today, I will go through the agenda for the webinar today. Firstly, I will give you an introduction to ModuleWorks, a bit about the company itself, who we are, and what we do. I'll then go on to give you an introduction to the product which we call CNC simulation and how we define this. I will then pass over to Mark, who will tell you about the benefits and features of CNC simulation with collision avoidance, a bit more technical insight, and he'll go through our proven experience in CNC simulation. He'll also explain the integration of the product. He'll also show you a video of one of our integrations on a fan-out controller, and he'll also explain the different levels of this product itself. I will then take over from Mark and give you an overview into the pricing model at ModuleWorks. So I will get started. ModuleWorks is an algorithmic laboratory and a software development house. Now, we're a component provider to CAD/CAM companies and to CNC companies who we provide our technology to. Our partners then integrate our technology into their products. So we work on a business-to-business basis, and we ourselves don't provide any end-user products. We've been working in the development of CAD/CAM software for more than 20 years. The origins of the company goes back to the 1990s when our managing director and founder, Mr. Yavuz Murtazaoglu, developed our initial 5-axis toolpath calculation component. And we are fully independent and are a neutral supplier, offering a full range of toolpath creation and simulation technology. In this slide, I'll give you some background information about us. ModuleWorks' head office is in Aachen, in Germany. Aachen is the furthest western city of Germany, right on the border of the Netherlands and of Belgium, what we call the heart of Europe. We currently have 85 developers working for us in our headquarters in Germany and also in our development centers in Romania and in Ukraine. And we have additional team members in the UK, the USA, and also Russia. At the moment, we have more than 125 employees worldwide. This means that we have a technological army to maintain our cutting edge in our technology. And under our belt, we have more than 500 man-years of code writing, with more than 10 PhDs contributing to the code. As you may have gathered, we're an international company with international customers and also employees. At present, we have 50 nationalities of employees working for us, and our customers span throughout the whole world. And our corporate language is English to ensure good communication between our internal offices and also our customers. We're very proud of the fact that ModuleWorks grows at an average growth rate of 20% per annum. And we hope this will continue. We've recently been awarded by the German government for diversity in business culture. Due to the vast cross-section of employees we have, we provide the infrastructure so that new employees can fit in Germany. And we're also very proud of the fact that for the 3 last years, we've won the Great Place to Work award. Moving on to us as a supplier. We're a single source supplier for toolpath calculation and for simulation. We have 60% of the market share worldwide, and we're growing. We estimate that every day more than 250,000 CAD/CAM, machine tool, and CNC control end users worldwide utilize ModuleWorks technology every day. At the bottom, you can see a graph showing our number of customers in the last few years vastly increasing. On the right-hand side, you can see our official logo partners. One point to note is that we do have a substantial number of confidential customers who aren't shown here on the right-hand side. Here you can see some of our bigger customers in the CAD/CAM area, which I'm sure you'll recognize, and also in the CNC technology area. So I will give you an introduction to the topic of CNC simulation with collision avoidance. Now, what is CNC simulation? What we call CNC simulation is a software solution that can be integrated directly onto the HMI or CNC control for the purposes of simulation and to provide real-time collision avoidance whilst operating the machine. I'm going to pass over to Mark now, who will go a bit more into detail about the benefits and features, and who will be able to give you a technical insight into the product itself.
Okay, thank you, Ben. I would like to continue with the benefits of CNC simulation with collision avoidance. This technology reduces the risk of downtime and expensive collisions inside the machine environment. That means the tool, the workpiece, and machine parts such as the spindle by using real-time look-ahead data. If we run the machine or the control in dry run mode, we can reduce the stock wastage by previewing the part program. If the machine window is obstructed by, let's say, coolant fluid, if you cannot see the machine moving, the live simulation can be of benefit, such as a virtual machining window. And if we connect our simulation environment to a virtual CNC control, you can use this experience to train new users who are not familiar with the CNC. Next, I would like to introduce you to the main features of CNC simulation. First of all, our goal is to have a full integrated, realistic virtual environment, which can simulate not only multiple workpieces, but also multiple turrets, the whole complex clamping mechanism with jaws, fixtures, and the many different tools that are available for mills and lathes. From a technology point, we simulate both simple lathes and mills, but also complex multitask turning centers with multiple synchronized turrets and channels. The real-time clash detection allows stopping the real machine when using look-ahead data. Simulation is available in all the different operation modes, so not just automatic mode, but also jog mode and MDI. The big benefit is that we do not need to parse the G-code. Instead, our simulation technology uses the actual axis positions as they are calculated by the CNC or by the interpreter and interpolator. The big benefit of this is that we simulate exactly the same data that also gets sent to the real drives. We have customized solutions for real CNC hardware and software, like low-end CPUs, x86, mainstream hardware, but also ARM CPUs, ARM-based technology, and different operating systems such as Windows, Linux, and even Windows CE. Requirements like real-time simulation, guaranteed response time, memory limitations of the host hardware and software are well-known topics to us, and we can address these during the integration phase. We are also highly specialized in the CNC manufacturing sector, and we have proven experience with both CNC control makers and machine tool makers. Next, I would like to show you a case study where we have connected a FANUC CNC controller to our simulation technology using the Focus library and using a HSSB connection between the controller and our simulation. So what we can see here is we have two tools moving. One is transparent, which is the look-ahead data, and we have the standard solid tool. So let's just skip the first part of the simulation. And here we can see how the tools are moving in a synchronized fashion. So we can see the look-ahead tool is moving at least 600 milliseconds in front of the actual position, actual tool. And we are using the look-ahead position to do the collision checking of the machine environment. And this is using the Forecast 3D interference check, which is a standard functionality available on Fanuc CNC controllers. So far we have seen the collision avoidance running in auto mode. This is also available in jog mode. So now we have switched to jog mode, and we can see how the tool is turning towards the table, and it would cause a collision between the table and the tool holder up here. In this case, the CNC controller is also notified about this collision, and machine operation is no longer possible. So let's take a look at a different scenario. In this case, the Z-axis is moving downwards, and a operator might expect a collision between the part and this part of the tool, and might be focusing or putting all his attention in this area. But in fact, we see that the tool will actually not collide. Instead, it's the spindle geometry up here, which will be touching the impeller geometry up here. So if the machinist would have been focusing on this area down here, he would have missed this collision and damaged the spindle. Again, we have a different collision between the tool and the workpiece. And even in jog mode, we are also able to do material removal with full collision detection capability. Okay, let's move on to the integration of CNC simulation. Our modules, our components are optimized for fast integration to allow you to simulate live process data as easily as possible. It's quite straightforward to create the kinematic models because you only need an XML file structure which defines the whole kinematic chain. Our components come with both the C++ and the .NET API. We have documented examples. We have a full API documentation, which will make it easy for you to get started. We also have a integration department that can give you advice and support throughout the whole design and implementation phase. And we also offer high-level support tailored to each customer's needs. Okay, let's take a look at three different options of how CNC simulation with collision avoidance can be integrated. Starting off with a basic integration, which we call material removal simulation. In this case, we are only simulating material removal, so there's no machine housing. So what do we need? First of all, we need the stock definition. This can be a simple model, for example, a box defined by points, or a cylinder for turning, or it can be any kind of 3D complex STL model, for example, for cast models. Then obviously we need to know something about the tool definition. For milling tools, they're quite simple to model. Basically, we just need the length and diameter. These are information that are typically available inside the CNC control. Additionally, we also need to know what type of tool we are using. Is it a flat end cutter? Are we talking about spherical mills, taper mills, etc.? Or in a more generic term, the 2D profile of the cutting part. For turning, it can be either a 2D solid geometry of the cutter, which is just extruded, or to be more accurate, the whole 3D STL geometry of the cutting part or of the whole turning tool. Where do we get the motion data? Obviously, it is connected to the CNC's interpolator, which can either output tooltip position. So if we are in workpiece coordinates, that is sufficient. Or if we want to simulate the entire kinematic chain, we can use machine axis values, but in this case, we also need to know the axis configuration. The fixture definition can also be imported in this scenario, but it is optional. One step further is the machine simulation. So basically doing material removal simulation and also collision detection, but not collision avoidance. That is this scenario 2 or option 2. All the other requirements are the same, except in this case, we also need the machine components as 3D STL geometry. Of course, this is optional. If we remove this, we are back in option 1 with the material removal simulation. And last but not least, the full benefit comes with collision avoidance. Basically, we need the same data as with machine simulation. And if we are connected to the look-ahead values, the look-ahead data from the CNC control, then we can do the whole collision avoidance, meaning we stop the machine before a physical collision actually damages the machine. Okay, that was it from my side, and I would like to now return the presentation over back to Ben.
Thank you very much, Mark. Right, in that case, I will move on to our final slide for today, which is the pricing for CNC simulation. I'd like to make a point that the price for component software is much less than the price for end user software. So if you were to have a price proposal from us, you may be surprised with the technology which we do provide to our OEM customers. We do have a very wide range of customers, ranging from very small companies to very large companies. Customers of ours may sell thousands of licenses, others may sell tens. And what we offer is an adaptable and flexible pricing model to make sure that our pricing can fit in with your business model. We essentially have three types of pricing models. The first one is on a fee per seat basis. This is where a fee will be agreed based on the number of licenses sold per year, and the fee would be adjusted accordingly. And this is the pricing model which we established for most industrial CAM vendors. We do have a percentage revenue system. This is where there are two options. The first one would be a percentage revenue of the total CAD/CAM revenue for one of our customers. Another possibility would be a set percentage of the end user price of the system containing our technology. The last option is very attractive to customers of ours who don't want to be involved in reporting how many sales they've made during a year, maybe companies with very large amount of sales, and this would be a fixed fee which we offer. As far as the pricing of the CNC simulation product go, there are three levels of pricing. So the cheapest option with the lowest functionality would be the CNC simulation product with material removal simulation only. The next step with a slight premium would be the product with machine simulation, including material removal simulation. And the final and most advanced version would be the machine simulation with collision avoidance, also having the highest price. If you do have an interest in exact pricing, then please do contact either myself or your dedicated account manager if you do have one, and we'll be able to discuss this more in detail and to give you a price proposal. That was the last slide for today. So I will go through a quick summary of what we saw and what we spoke about today. Firstly, I gave you an introduction to ModuleWorks, about the company itself. So I hope you have a bit more of an idea as to who we are and where we come from. I then introduced the topic of CNC simulation and passed over to Mark, who then presented you the benefits and features of the CNC simulation product and gave you a bit of a technical insight, and also told you a bit about our CNC simulation business unit and our proven experience in this area. Mark also gave you a background into the integration of the CNC simulation products, and also the different levels of CNC simulation available. And lastly, I introduced the topic of the pricing models which we can offer. So that's everything from us for today. Thank you very much for joining. I hope you enjoyed the webinar. And as I mentioned earlier, if you do have any questions at all, please do contact us. We'd be happy to advise you. Thank you very much and have a nice day. Bye-bye.